Hey guys, so this is going to be a short video on the stack implementation. I would be implementing the stack data structure both through the linked list and the array. So I will be creating a separate video on the implementation of stack in the standard library in C++, but this video will only be restricted to an array based and a linked list based implementation for the stack data structure. So I would be opening my folder, and now inside this folder I would be creating my file and naming it as stack array. So my first code would be an array based implementation of the stack data structure. So now, as you all know, that it follows the first in and last out methodology. So the element that is pushed in first at the stack is the last one to go out. So what we need to do is that I have to included the iStream, and now I will use the namespace. And now what we need to do is that we need to create a stack class, and now inside this class I need to create my private member variables. So my member variables would be the top of the stack, and then I would have the capacity, which I would use a constructor to initialize it to the size of the stack, and then a pointer to the array. So now moving on to our constructor, I will pass it the size, and inside this what I can do is that I can initialize my capacity to be equals to size and my top to be equals to -1, and I also need to dynamically increase the size of my stack. So I will use the new keyword. So array is equals to new int uh, capacity. Yeah, so this should be it for my constructor. Now moving on to our first function, which would be to add a value or to insert an element in a stack. So it would have the return type of void, and I will name it as void push. I will pass it the value. So what we need to do is that we need to do we need to just increment the top and replace it with the value. So basically, I'm trying to say is that we need to do this for this function. So most probably what will happen is that I missed the spellings of the array. Yeah, so this will basically push any element into the stack in order of the first in last out strategy. But we also need to do some error handling. If the stack is full, we need to tell the user that we could not add more elements into the stack. So what I can do is that I can use an if statement that if is full, which we will create this function later. We would just simply print that stack overflow, and this would be uh, yeah, and then we also need to return basically, yeah, and this would be executed in the else case. So our next function which we need to create is to remove an element from the stack, which would be a pop function. I will again pass it the value. By the way, for this function, what we need to do is that we do not need a value, as we will just be deleting a value from the stack. And in this case, for the error handling, what we can do is that we again can use an if statement that if it is empty, what we need to do is that we simply need to print stack underflow. and again we need to return. We can return -1 to indicate an error. So else what we need to do is that we just need to return the arrays top minus minus. So moving on to our next function. Our next function would be a peek function. So what basically a peek function does is that it just returns the element that is on the top of the stack. So for this, what we just need to do is that we need to return arrays top. Again, you could use an error handling check over here that if the stack is empty, you could return no element exists, and same is the case with other functions too. And now I need to create the functions, the is empty and the is full functions, and then we would move on to the function to print the stuff. So this function would be a function with type bool. So bool is empty. In this function, what I need to do is that I simply can return top is equals to -1. It will basically check if it is true, it will return 0, and if not, then -1. And now my next function would be to create its full function. And again, now for this is full function, what we need to do is that we do not need to check directly what the top is, we just need to check what the size -1 indicates. If there is an element, so basically the if the value after size -1 equals to the capacity of the stack, so we can simply return a true statement, otherwise it will directly be false. So I will just write return top is equals to capacity -1. And now my last function would be to print the stack. I will name is at I will name it as void print. And now inside this function, what I need to do is that I just need to print. So I will just indicate that stack elements in the stack are. So now what we need to do, I just need to add an end line over here. So what we need to do over here is that we need to run a for loop that would run from I is equals to 0 till the top of the stack, and we will print out the elements of the array on each of the ith indices. So for int I is equals to 0, I is less than or equals to top, uh, what we can do is that we can increment I. And now what we need to do is that we simply need to print the arrays ith index, and for better formatting I could give space. Yeah, so this should be it for the implementation. Now I will head on to the main function. So now inside my main function, first of all I need to create an object and initialize the size of my stack, which would be 5 in this case. And I could push elements, basically I start push. I can push 5, then again s dot push. Yeah, so I could add multiple uh, 5, 10, 15, 20, and 25. So now what we can do is that I could call the print function to see if the elements are successfully inserted. Yeah, so now I will run my function. Yeah, so upon running the code, we can see that the elements are present in the stack, starting off from 5 and then going on till 25. So now I will use the pop function to see if it successfully removes the element of the stack. So now in this case, when I print, my stack should end at 20 rather than ending at 25. So upon running the code, yeah, so it successfully pops the element from the stack. And now what I need to do is that again we can just again use a pop function and again push a new value which would be 27, and now I will use the peek function to see what element is in my stack at the top of the stack. So element at the top of the stack is, yeah, so now it should return 27. It hasn't returned 27. What is wrong? Just a minute. Yeah, so now it should work. Yes, as you guys can see, element at the top of the stack is 27. So now this is basically a really easy implementation of the stack data structure using an array. So now I would be writing the code to implement the stack using a linked list, which is a bit more challenging, but it's really worth it. So I will name my file as stackll.cpp. Again, I would create my header files. And yeah, so rather than creating a stack class directly, I need to create a class node first. And now inside this node class, I need to create the members, which I would make them public. So int data and node start next. And now I would be creating my stack class. And now inside the stack class, I would be using my private member variables, which would be node start top and size of the stack. Yes, just a spelling mistake in the size. And now in my public uh, member variables, I would create a constructor first to initialize things on this code. So in this constructor, I would initialize the top to be equals to null pointer and the size to be equals to 0. And now I would be moving on to create the functions. So our first function again would be as usual to push any value in the stack. So to push a value in the stack, I would be creating a new node. So I would name it as temp and new node. Yeah, so what we need to do is that we need to, so basically the data in this new node should hold the value, and the next to what this node is pointing to should point to the top of the stack. So temps data should be equals to value, and temps next should be equals to top. I hope we are doing it right. So now we again need to update the top to be equals to temp. Yeah, so yeah, we also need to increment the size of the stack. So our next function would be to pop any element from the stack, again of return type integer. So I will not be using any error handling statements in this linked list code specifically because it just makes understanding a bit more difficult. So just to directly implement the pop function, I would create a pointer to temp, again name my node as temp. So again, I would initialize it to top. Yeah, so it should have a single p. So node start temp is equals to top, and what we can do next is that int pop value. I can name my value as the pop value, and we can in this we can store temps data, and update the top to be tops next. And now what we can do is that we can directly delete temp. Yeah, so this should be it. Oh, so we also need to decrement the size and return popped value. Yeah, so this should be it for the pop function. And my next would be to implement the peak to see the top element of the stack. So for this, what we need to do is that we just need to return the data which top holds, which would be just the value at the top of the stack. And to get the size of the stack, we can implement a get size function. And in this function, we can simply return size. What is wrong in this function? Yeah, so this is fine now. And our next function, so basically our last function would be simply to print the stack. So to print a stack, it's basically very easy. Just as you print a linked list, a singly linked list. So I will create a node to store the top of the stack. So I will name it as current is equals to top, and I will use a while loop. So while current is not equals to null, what we need to do is that we simply need to print the data for each node, and with that we need to also update the current pointer so that it moves forward after printing the data of each of the previous node. Yeah, so this should be it, and I will now implement the main function. So inside this main function, I will again create an object. I will name it as s. And now what we need to do is that we can simply perform multiple operations. Stack.push again 4 and stack.push. So So basically, a good use of the linked list is always that it is not fixed like an array. Your stack could be of any size. You could insert as many elements as you want in your stack rather than to be bound with an array that has a fixed size. As dynamic memory allocation becomes a bit more, so basically what dynamic memory allocation in an array does is that it is not that optimized like how the linked list works. So the linked list code would always be faster than the code that contains a dynamic memory allocation using an array or a 2D array. So I will insert further elements, 16, and I will end with 20. So I could now print. So why not I add this statement over here, that cout elements in the stack are, yeah. So now I can just directly call the print function, start print. So now upon running the code, you would be able to see the elements that are inserted at the stack. Yeah, so using this, what basically it has done is that due to the reversal of the elements, you guys can see that the pop the push function uses this strategy or the way to insert the node at head. So if we change this and directly so if we change this and write it in the way to insert a node at the tail of the linked list, so these elements would be printed in ascending order rather than descending order. So what so with this code, what we can also do is that rather than inserting them in an ascending order, we could insert them in a descending order at the head of the linked list, then print so that they are printed in the so that they are printed in descending so that they're printed in ascending order. So if we write them in this way, now you would be able to see that it works pretty fine. Yeah, so again, what I could just use the pop function. So now my stack linked list should just end at 16 rather than 20. Yeah, so basically it just removed 4 as 4 was at the top of the stack. And now again what we can test is that we can use the s dot peak function, which will return the top element of the stack. So the top element of the stack would be obviously 8. So I could just write that the element at the top of the stack is, yeah, so it should print 8 in this case. Yeah, so as you guys can see, this code is working very fine. So this is the code, and I hope you guys enjoyed my video. It's basically relatively easy. It looks easy, but it is used widely in many applications in networking too. So I will create a video shortly after a few days on the standard library implementation of the stack data structure, and again I would be creating a video on the queue data structure also. So that's it from my side, and do like, share and subscribe.